A system of equations is more than one equation with the same variables. To solve a system of equations, we need to find the values that make all equations true. In example 1, we have a system of equations. Here's our first equation, and here's our second equation. One of the ways we can solve a system is by graphing. So to solve this system by graphing, we're going to graph each line. To graph this first equation, I'm going to solve for y, so my equation is in slope-intercept form. So the slope of my first line is 2/3, and my y-intercept is 0. So I'm going to graph this line. Y-intercept of 0, slope of 2/3. Now all of these points on this line make this first equation true. They're all the ordered pairs, the x and y values, that give me an equivalent statement. To graph my second line, y equals 4, y equals a number is a horizontal line. I'm going to have a slope of 0, and it's going to go through the point 4 on the y-axis. So my y-intercept is 4, and then I have a slope of 0, which gives me a horizontal line. Now all of the points on this horizontal line make my second equation true. In this graph, I have intersecting lines. Whenever I have intersecting lines, my solution will be at the point where the lines intersect. In this case, this solution is going to be at the point 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. The ordered pair 6, 4 makes both equations true. I can always check my answer by plugging in x equaling 6 and y equaling 4 into my equations. So 2 times 6 minus 3 times 4 should give me 0. So this solution works for my first equation. It makes my first equation true. And for my second equation, I don't have a place to plug in my x value, my 6, but I do have a place to plug in my 4, my y value. So I end up with 4 equals 4, which is also true. So this point is my solution. In the second example, again I have a system, 2 equations, both with an x and a y in them. To solve this system, I'm going to graph both lines by solving for y. So the slope of my first line is -1, and my y-intercept is 5. Now I'm going to solve for y in my second equation. So the slope of my second line is -1, and my y-intercept is -4. Now all of the points on this line make my first equation true, and all of the points on my second line, or on the second line, make my second equation true. So which values make both equations true? Well, in this case, I have parallel lines. And parallel lines means that I have two lines that never intersect. And if these two lines never intersect, there's going to be no points that are common between them, which means for this system, I have no solutions. So whenever I have parallel lines, my answer to the system to solve this system is no solutions. I can find points that work for my first equation, and I can find points that work for my second equation, but I can't find any points that will make both equations true. And that makes sense. I can see that both slopes are -1, and the y-intercepts are different, which gives me those parallel lines. And my final example. Again, to solve by graphing, I'm going to solve for y. Negative times a negative gives me a positive 1/4 x. A negative times a negative gives me a positive 1. So the slope of my first line is 1/4, and my y-intercept is 1. Now all of these ordered pairs on this line make my first equation true. Now let's graph my second equation. Again, I'm going to solve for y. Negative times a negative gives me positive. This should be a 1/2 right here. 1/2 times 1/2 gives me 1 times 1 over 2 times 2. And a negative times a negative gives me a positive, and 1/2 times 2 gives me 1. So the slope of my second equation is 1/4, and my y-intercept is 1. Which ends up giving me the exact same line. Since I have two lines that are right on top of each other, these lines are called coincidental lines. When I have coincidental lines, any answer I can find that works for my first equation will automatically work for my second equation. And any answer I can find for my second equation will automatically work for my first. So any point on this line is a solution to this system. So I have infinite solutions.